Hey everyone, it's Jim
and Charles
from Mellow Amps, and in this episode we're going to start soldering. Okay, so you should grab your parts list. We're going to do all of the resistors, and we're going to start with the 4 diodes. You've got some nice little check boxes, so we'll talk a little bit in a second about how to make sure you got the right resistor into the right spot, but let's just get started. So you've got 4 diodes, and on your parts list you'll see that the diodes are going to be marked as 4 plus 1. So I'm just going to snip off the one end. Now notice how we're color coded, and there's a band on the diodes. Diodes can only go in one direction, and these great PCBs that Charles designs are really well labeled. So you can see that there's a band, and there's a band, and the red tells us the band is up there. So I'm going to put one in with you, and then you'll know what you're doing. So it's really important that you size and that you bend your lead carefully. So any kind of bamboo skewer will work really well, especially if it's got a taper, because you can use the taper to kind of determine
just how hard the bend will be.
Yeah, and where you're going to put the bend. So that's pretty good for this one. Normally I would now go ahead, I would do them all. But we're just going to get one in, or this video will take, an hour, and nobody has an hour to watch us yammering on. So now, pay attention. The band has to go in the right direction. So you see that, and the band's fairly faint. So in it goes, and there we go. Now, you should be fairly close. You can work it a little bit to get it in, but if your bend is really off, just pull back the component and redo the bend. Now it's a preamp, so it's a low-powered device, so it's not absolutely necessary to do things like lift the diodes up, so they can sit flush to the board. Normally, if you have a component that's going to get really hot in service, you would actually put a little space on the board. Now, I'm going to show you how to do a version of a NASA soldering job. Now, the preamp's not going to the moon, or to...
Not yet, anyway.
Or to Mars. Well, maybe someday somebody will bring their tube gear with them.
I think that would be fairly expensive for a space flight.
How do electrons work in low G?
Probably the same as high G.
So, it's important that you start with a properly tinned and cleaned tip and at a good temperature. So this is a fairly small component, so let's try 360C, which is 680 Fahrenheit. That's at the top end of what I would do as a temperature range. But what I like to do is I like to get in and out fast on a component. I don't like to linger. That's when you can possibly overheat something and damage it. And I'm doing this in real time so you can get a sense. So a little drop of solder on the tip. Notice how I've angled my chisel tip, because I don't need that big honking flat surface. What I need is just that little edge is all I need. As soon as it starts to melt, I fill, I hold for a second, and I let go. Now if I had all 4 of these in, I would actually hop from this one to the next one to the next one before I did the other side. And what that does is distribute the heat around a little bit and reduces the chance of overheating a component. I've got such a bad memory, I don't remember if I put a dab of solder flux on there.
You did, yep,
I did.
You fluxed it.
Okay, that's why Charles is here. Okay, now, you're probably doing all 4, but we're just going to do one. So now,
it's a good idea to hold on to the leads after you've let them cool down a little bit, or they'll go flying everywhere.
Yeah, now you can also hold it over a garbage pail and snap them off into the garbage pail. Be really careful though flying leads can actually get into your eyes, into your toes. Ask Charles how he knows about the toes.
Thankfully, no eyes yet. But if you are going to let them fly, wear eye protection.
Okay, now these are double-sided boards. It's not absolutely critical that you solder both sides, but if we're going to do a quasi-NASA grade soldering job, it is. Now, if you've got a good touch with your soldering iron, you may have well flowed through already, and you're done. And if not, you can come back and you can just do a little touch up on this side. You don't need to add any flux. The flux will have flowed right through and it'll be all ready to go. And in fact, we could use just a wee dab right here, Charles. So this is probably not really necessary, but I want to show you how to do the other side. So you just come in and just fill a little tiny bit and get out of there. Okay, and you're always cleaning your tip off. Okay, so pay attention to the orientation. The diodes alternate, right? And the circuit will not work if the diode's in reverse. So, okay, go ahead and get the rest of them on, and I'll see you right back. Okay, so the parts list is going to really help get us organized. We're going to start, after we get those diodes all in, we're going to start with the smallest value resistor and work our way through the parts list. So let's start with R3, which is a 1/4 watt 220R. Now, it's really important that you put your resistors on an ohm meter just before you install them, and you really pay attention to what your meter is telling you the value is, because sometimes you'll end up with, let's say, a 220K and a 220 ohm or 220R resistor, and you miss it. So we've already got one R3 on the board. Now, the boards are extremely well labeled. There is no R3 on the back side, so you always position your resistors where the pad is marked. So this is just like installing the diodes. We put the tiniest amount of flux we can, so we make as small a mess as we can. Resistors will typically get soldered on the board at about the same temperature as the diodes, so 360 C or 680 Fahrenheit. Now, if your solder is flowing way too fast and it's not making a nice little flattened volcano, turn down your temperature a little bit. And if your solder is not flowing fast enough, it takes forever to heat up the pad, then turn up your temperature a little bit. Everybody's iron and solder is going to be a little bit different.
Just pay attention to how it's reacting and adjust for it.
So even with my big 1/8 chisel tip, I'm going to solder this small component, but I'm going to do it on the angle of the tip, of the chip, of the
angle of the tip.
Angle of the tip, just like I did the diodes. So I put a drop of solder in, and it's melting nicely. I fill, and I'm off. That little hold after I fill is important. Now, the smaller the component, the shorter the hold, right? Okay, so let's get in there and just snip the leads carefully. Let's have a look at the other side. I got nice flow through on this side. If we're trying for our quasi-NASA soldering job, we would come back here and we would just touch up this side. We don't need any extra flux. The flux will have flown through, and we're just gonna, it's just the same as we did the other side, only it's much quicker. You don't want to linger when you're filling in the second side. Now we've soldered both sides of the board. That's a really good electrical connection. So just work your way through the resistors logically. So if there's 2 R3s listed, and there were, put them both in, and then check your schematic, your parts list, sorry, and look to see, okay, well, what's next after the 220R 1/4 watts? What other 1/4 watts do I have? I have 2 R10s that are 15K. So that's what I would do next after I got in after I got in R3. And before I move on, I'm going to tick off the box to show that I've actually finished it. Okay, I think you know what you're doing. Hop to it, everyone. Okay, one more little tip. There's going to be labels on most of the components you put on, or banding, as in the case of the resistors. Some of the resistors actually have it all just printed depending on the size of them. It's really good practice to put them all oriented in the same direction. They could be all going this way, or they could all be going this way. But what that does is it allows us, if we're troubleshooting to make sure we got the right resistor in the right spot, it's really easy to see the band colors oriented if they're both in the same direction. If you turn one around, your brain does a backflip and says, "What the heck?" Anyways, that's very good practice. Okay, carry on, everyone. Okay, I hope everything is going well. I want to show you something that caught us. We should know better. But sometimes you think of resistors as being mounted in pairs, such as way down here. R10 is beside R10 A and B. But up here, we goofed up. Well, who goofed up?
We won't say.
Okay. Well, I'll take the blame because I clearly goofed it up. Anyways, R7 and R6 are actually beside each other here, but they're different resistors, yeah? And up here are R6 and R7. So what you want to do is when you get to R6, make sure you put R6 in place here, and R7 here and here. So it's amazing. The brain thinks in terms of like experiences, and I just put both R6s here and soldered them on the board. Anyways, we fixed it. So
we make these mistakes so you won't have to.
So just pay attention. So we're at the point where we're putting on R8A and B. So notice how I bent it so the label's up. These are bigger powered resistors. They're way oversized for their application, but
that's good practice whenever you're working with power resistors.
Yes. Yeah. And the reason for that is a couple of things. One, you want to make sure that you're nowhere near the actual requirement of the resistor. And the other thing that happens with resistors is that their rating goes down dramatically as they heat up. So,
which is something that power resistors typically do.
Yeah. So you go way oversized to make sure that you won't have a problem. Now, these are bigger resistors, so we're going to use a tiny little bit more flux. Not much, but just a little bit more because it's a bigger wire. And we're going to bring our temperature up a little bit. We did everything else at 360 C, 680 Fahrenheit, and I'm going to bring these up to 370 C, which is going to be almost 700 Fahrenheit, just under it, I think 695. And of course, the rule is the bigger the component, the hotter it needs to be, and the smaller the component, the cooler it needs to be. Now, we're not talking about a big difference in temperature, but that little 10 degrees Celsius can make it. See how the solder is not quite taking nicely? So we're going to come up a little bit. We're going to go up to 375 C, which is 700 Fahrenheit. And I'm almost out of solder on my little nubbins, and I'm going to make sure I have a little bit more flux because I want to make sure to do a proper job here. And I'm going to clean my tip. A dirty tip won't conduct well. And one more tip while we're on the pro tips part of the episode. You need to apply a little bit of pressure when you're pushing your tip onto the pad and up against the lead, because that'll give you much better, oh, look at that, isn't that lovely?
Much better conduction.
Yeah. So when I first started soldering, I thought, oh, I want to be gentle with these components. Don't be afraid to put a little pressure and you'll get a much better contact. Okay, well, carry on, and I'll see you back when you're all done. Okay, so this is what your board should look like. You can see where we had to, where I had to get a resistor off. and swapped. But if you take your time, it's not a big deal. And if you're not sure how to desolder, go into the How to Solder episodes and they'll help you out. But that's what the this side of the board looks like. This is actually the socket side. You see it says install sockets on this side. And here's the other side of the board. This is the side that actually faces down. And there's only a handful of resistors on this side, but we've populated the entire board. And Charles, you've got our parts list all ticked off?
We've got it all ticked off, so let's bring that over here. So you can see we've taken care of the diodes and all the resistors, and it's time to move on to some other components.
Okay, well done everyone. That's quite a bit of the soldering done.